Hello and welcome to my presentation on the Kashmir earthquake of 2005. The setting of this is between the Indian continental plate and the Eurasian continental plate, where the Indian plate subducts under the Eurasian plate at about 4 centimeters a year. This produces the Himalayas, uplift and compression. On October 8th, at about 9 a.m. on 2005, our earthquake occurred, and there was a failure along this fault surface, the Balakot Bog Fault, which is about 75 kilometers long, and the first surface rupture observed in the Himalayas from an earthquake. The magnitude was a 7.6, and there was an observed slip of 4 meters. The depth of this fault was 26 kilometers, which is fairly shallow and contributed to its severity most likely. There were many aftershocks as well, ranging from magnitudes of 4 to 6.5, which are quite significant. This is a reverse or thrust fault as well, and dipping about 30 to 40 degrees. There were reports of shaking up to 45 seconds, but there was no instrumentation in the areas that needed it most, such as the northeast rural areas, which we can see over here. But we can see that there are still significant accelerations recorded just 35 kilometers away still, which is fairly far. We can see here the general ground movement, which we would expect the plate up here going up, Eurasian plate, and Indian plate going down. Landslides were very widespread throughout this event, mostly as a product of weak lithology or geology, as well as to proximity to the general rupture area. There was on the scale of 2 to 3,000 landslides induced by earthquakes in the area, but most of them were really small, shallow ones, like rock falls and debris falls, or rock slides and debris flows. There are only 2 landslides exceeding a tenth of a square kilometer, but the total slide area exceeded 7,000 square kilometers in terms of the cumulative. The first large landslide was a failure of a sedimentary and dolomite-dominated hill slope just next to Muzaffarabad, which was quite proximal to the rupture zone. This is probably why it failed. It had a volume of about 10 to the 6 cubic meters. The next landslide was the Haitian landslide, or Jhelum Valley landslide. This was classified as a rock avalanche due to its high velocity when it traveled, and it had a very large extent, being almost 3 kilometers long from the toe to the top of the scarp, and it nearly dammed 2 small rivers as well, somewhat similar to the Thistle landslide in Utah. So factors to why these landslides occur are dominantly due to proximity to the rupture zone, and as well as its orientation, with most landslides being southeast and northwest along the fault surface. Also, the hanging wall or the northeast position on the Eurasian plate experienced much more failure, which is somewhat surprising to me. We can see some more landslides. There were almost 80,400 people dead and 100,000 injured, as well as more than 3 million people left homeless as a result of this. Nearly all the residential areas or buildings, which were constructed mostly out of unreinforced concrete or masonry, had collapsed or were heavily damaged, and cities such as Balakot were 90% damaged. And yeah. The direct cost was 2.3 billion, but the overall indirect was nearly more than double that, and that is also due to the reconstruction costs and whatnot associated with all these damages to the buildings. This building could be an example of a good building to build, as it seemed to resist the earthquake and did not fail. Mitigation efforts implemented were mostly responsive and not preventative. The only preventative mitigation effort I could find was seismic hazard mapping and maybe just general outreach, but our zone in the northeast here was not even a zone 1, and after the 2005 quake, they did promptly change that near Muzaffarabad to zone 1. But the evacuation efforts to move people to camps and provide them with food and water was the largest priority in terms of the effort, but there was little preparedness in terms of this, and they needed lots of international help and effort in order to fulfill this. So my recommendations would be to implement an early response seismic system similar to Japan to try and know when these events are going to happen earlier and sooner. And this an important part is a bottom-up relief process to empower smaller communities so that you can help those who really need it in the rural communities who are most impacted, in addition to adhering to a strict building code.